Hi, we're going to preview Geometry Lesson 2.7, the homework problems that you were assigned for this lesson. So for Lesson 2.7, I have the actual numbers for the problems written, but I'm also going to circle the numbers, and this is something that'll keep you out of trouble when you're doing your homework. Well, it'll keep me out of trouble while I'm doing this video also. Our first set of instructions are use the figure for exercise 1 through 5. Do not use a protractor. So they're talking about the figure directly to the right, and let's just take a look at this figure. Now, before you begin, you should have paper, a pencil, and your lists of definitions, postulates, and theorems readily available. So they should be right there so you can see them, because your homework will be about what you learned in the lesson. So let's begin. It says, what kind of angles are angle G, KJ, and angle HKI? So G, KJ, right here, and HKI. What kind of angles are they? Well, we've learned a lot about angles so far, but what did we just learn? Well, we just learned about vertical angles, and that's what these are. These are two non-adjacent angles opposite each other. These are two straight lines, and that consequently means that these angles are vertical angles. Number 2, name two pairs of congruent angles. Well, two pairs is going to be 4 angles, 2 sets. So let's just talk about the angles that we just did. We know that vertical angles are equal. So we can say angle G, KJ, and angle HKI. And we can also say the other set of vertical angles, angle GKH and angle JKL. So we have 2 sets of equal angles that are vertical. Now this is something I like to do when I'm working on these type of figures, is I fill out whatever information I know. I know that vertical angles are equal. So right now I'm going to fill this in because I know that that's 55 degrees because it's equal to the other vertical angle across from it. Number 3, find the measure of angle IKH. So IKH. Now IKH is this angle right here. And what do we know about it? Well, we don't have this other vertical angle. We have no measurement for it yet, so we can't say that automatically. But one of the things we do know is that we've learned about supplementary angles. And supplementary angles are angles that add up to 180 degrees, don't they? Well, this whole angle here will be 180 degrees, and you know that part of that angle is 55 degrees. So the measure of IKH will be 180, and you can probably do this in your head, and that's not going to let me write that. Let's see what I can do here. 1. well, let me do it. 180 minus 55. And what is 180 minus 55? Let me give you a moment to figure that out. It's 25 degrees. Now at this point in time, I'd really prefer if you figure out these angles by actually writing them on your paper somewhere. So if you get them wrong, I can tell why. So we know that this is 25 degrees. 125 degrees. So I'll write that in my drawing. You should write it on your paper also. So you should have written this figure on your paper, and you're now going to do the degrees on the figure. And if this angle here is 125 degrees, guess what? Its vertical angle is 125 also. So it asks us now to find the measure of angle HKG, and we already found that just by looking at our drawing and using some of our rules. We know that that is 55 degrees. And number 5, what is the measure of the complement of angle JKI? All right, the complement is 90 degrees. So JKI is 55. So we need to know 55 plus what equals 90, or 90 minus 55, which equals 35 degrees. It also asks for a second part of that problem. So what is the supplement? Well, supplementary angles are 180. So 180 minus the 55 would be 125 degrees. So we're using from the lesson what we just learned. I'm going to change my pen size and see if this helps at all. Okay, name 2 angles adjacent to FGA. So we're now using this next figure. Angle FGA. There it is right there. It's 40 degrees. It says name 2 angles adjacent to. So these are the angles that are next to. So what angles do we have next to FGA? Well, we have FGE and we have AGB. So we have angle FGE and angle AGB. Number 7, name 2 angles that are supplements of angles FGE. This means that they have to add to 180 degrees. So here's FGE right here. This means we need this whole line or this whole line to be included. So for FGE to be part of a supplementary angle, we're now going to take this angle right here, which is angle EGC. And then we need to take the angle on the other side. So this was FGE. We're going to go from here and take angle FGC. You might need to use colored pencils when you're doing this, or erase every time you need to redo another angle, and that might make it easier to see. Okay, let's move on, and we have number 12, number 15, and number 16 that we're going to do. Okay, number 12, classify each angle by its measure. So, this came from a previous chapter, and angles that are less than 90, if you remember, are acute angles. If they're more than 90, they're obtuse. And if they're 90 degrees, they are right angles. So let's look at this figure. EGF. So this is EGF. Is that less than 90, more than 90, or 90 degrees? Well, EGF is right here. And it's a small angle. It is acute. FGB. FGB. This is the entire angle from here to here. And this is going to look really sloppy. Let's see if I can just fill it in a little bit so you can get a visual. So FGB, and that's obviously larger, and it's definitely not acute. It's bigger than a right angle, so it is obtuse. Now, angle EGC. This is this angle right here, and this is, I'm sorry, EGD. That's this angle right here, and it's got that 90-degree symbol, so it's a right angle. And last angle, angle CGF. CGF, that is the angle for the straight line, and that would be a straight angle. And this is write a statement illustrating each property. We had properties that we reviewed in this lesson: reflexive, symmetric. This is asking for the statement for transitive property. And transitive property is if A is there we go. My cursor disappeared. Here we go. If angle A, because we're doing this for angles, is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. Now, the way we've learned transitive property was if A equals B and B equals C, then A equals C. And if you write it that way, that's fine, because that is the property. They just expressed it here with the angles. And number 16, name the definition, postulate, or theorem that justifies each statement. So this says, if the measure of angle M equals the measure of angle N, then angle M is congruent to angle N. And we use this several times in our proofs. This is the definition of congruent angles. Let's move on to some more homework. Number 21. Use the figures to find each value. Now we've learned about adding angles, and these figures will be the same thing. It's just that they have algebraic values in them. So it asks us, what is x? And to find x, we need to make some equations. One of the things we know is that these two angles are vertical angles. So we have numerical values in both, and let's go ahead and make an equation using both. So 7x plus 6 equals 13x. Using distributive property, 7x plus 42 equals 13x. Combining like values on both sides will give us 42 equals 6x. And now we divide by 6 on both sides, and x equals 7. Let's look at the measure of angle AED. AED is this 7x plus 6. We already know what x is, so we can just substitute in the value of x in the equation. So it was 7x plus 6, and the x we know is 7, so that would be 7 times 7 plus 6. 7 plus 6 is 13. And 7 times 13 is 91 degrees. And now we have to look at CED. There are no values there, but what we do have for CED is that the measure of angle CED is part of a supplementary pair. Let's look at that. So CED is part of this supplementary pair, and we already know that this angle is 91 degrees. So we can say for C that 180 minus 91 equals 89 degrees. Okay, number 23. Number 23 is very similar. We have a 90-degree triangle. We have values for both. They want us to solve first and foremost for Z. So what can we say? Well, one of the things we know is that these two angles together equal 90 degrees. So let's go ahead and set them to 90. And we have 4Z plus 7Z plus 2 equals 90. 4 and 7 is 11, so 11Z plus 2 equals 90. Subtract 2 from both sides, 11Z equals 88. Divide by 8 on both sides, and z equals 8. So this is the answer for A. And from here we can go on. 23b, the measure of angle GHJ. GHJ, that's the 4z. So for B, that would be 4 times, and we know z equals 8. 4 times 8 equals 32. And for C, we have the measure of angle JHK, and that is the 7, So once again for Z, we have 7, and the Z we know is 8 plus 2. And 7 times 8 is 56, plus 2 is 58. Now you could also have solved that by using the complementary angles, and you knew that 4z was 32, so you could have also said 90 minus 32 equals 58. Number 25. Supply each missing statement. So the way you need to work these is take a look at your notes and what is transitive property of congruent angles. That's the A equals B, B equals C, so A equals C. So in 25, if 1 equals 2, or 1 is congruent to 2, and 2 is congruent to 3, then angle 1 is congruent to angle 3. Number 27. W is a point in the interior of angle XYZ. We're going to use angle addition postulate to figure this out. Okay, probably the easiest thing to do would be to draw a picture. And my picture is mysteriously right here now. So this was angle XYZ. W is a point in the interior, and we know that we can make a drawing like this because if you look back at your angle addition postulate examples, you'll see a drawing just like that. And they want to know what added up to give you this definition of angle addition postulate. Well, the measure of angle X, Y, W plus the measure of angle W, Y, Z equals the measure of angle X, Y, Z. So it was this angle added to this angle, and that forms the whole angle. Number 29. Where we have some given, we know that the angle A and angle B are supplementary, and that's the definition of supplementary. So what happens? What do we talk about before we talk about two angles that are supplementary? Well, we declare that they're going to be a certain amount of degrees. And you'll see that pattern in your proofs that you've already done and in your definition. So I have two angles, A and B. The measure of one of the angles plus the measure of the other angle equaled 180 degrees. You could have called these angles anything you want to, and this will work. Number 32 and number 33 are next. And it says, given that all right angles are congruent, and we can see a picture over to the right here. It shows two right angles, angle A and angle B. We need to prove something. We don't know what that is. Well, let's do some backwards thinking. Use some logic. And we already have our proof written in the statement. There it is right there. That's what we're going to prove. So we're going to prove that angle A is congruent to angle B. Sometimes we can work these statements backwards. Now something I'm going to show you. This is a pattern. Make notes on this pattern. Remember this pattern. This will repeat over and over and over. In the third step, it shows you that they took the measures of angle A equal to measure of angle B, and then the fourth step, it's angle A is congruent to angle B. We've done this possibly 4 or 5 times already. So we know that to do this, we use the definition of congruent angles. Over here we have the given, so let's fill that in, and the given was angle A and angle B are right angles. So that we can be sure of. Now it's the next step that you haven't done yet and you might not be sure of, but what do you know about right angles? Ask yourself this when you're doing a proof. Well, what do we know about the measure of angle A and the measure of angle B? Well, they're 90 degrees, right? And they are 90 degrees by definition. So we can state that the measure of angle A equals 90 degrees. And the measure of angle B equals 90 degrees. All we have left is one step. So if their measure is 90 degrees and they equal each other, what did we do from this step to this step? Well, they were right angles, and we substituted their measure to show the definition, so we used the substitution property. And that proof is done. Number 33. If two angles are adjacent and supplementary, then they form a linear pair. This is one of the theorems that you already learned. This is the picture that goes along with it. So we're given angle 1 and angle 2 are adjacent and supplementary. That's already written in for us, and that will be our given. Our proof is not in here yet, so we'll have to figure that out. But we do know that they're adjacent and they're supplementary. So let's go ahead and by angle addition postulate add them together. So the measure of angle 1 plus the measure of angle 2 equal the measure of angle AXC. Our next reason we see is a definition of supplementary. We just did that in the last proof. So let's rewrite that. Measure of angle 1 plus the measure of angle 2 equals 180 degrees. So this is the exact same step we took in the last proof we just did. That's why you want to have these things in your notes so you can look back and see them. Our third step, the measure of angle AXC, which is the straight angle, equals 180 degrees. What have we done here? We've taken this measurement right here, and we've taken this one, and we've now set them equal to each other. Does this sound familiar? This is substitution, or you could even say transitive property. Now we can state that angle AXC is a straight angle, and that's because of its definition. Straight angles are 180 degrees. And what were we trying to find? We were trying to find that they were a linear pair. Remember, this is an if, then, so it has two statements, and if they're adjacent and supplementary, then they're linear. We just proved that they were adjacent and supplementary. So the definition of a linear pair, we can actually state that angle 1 and angle 2 form, or you could say are a linear pair. Now for 40 and 41, it's asking you to make two proofs. Here's what I want you to do. These are the first two things that we're going to do on the board tomorrow. Right now, for prep, on your homework paper, I want you to put number 40 and set up a two-column proof that has 4 steps below the statement and reasons. And that'll be 4 steps for both number 40 and number 41. I want you to have a picture made next to the proof. They use the same picture for both 40 and 41. And when you walk in tomorrow, we'll be working on this right away. The rest of your homework, number 48, 51, 53, and 55 are review. And I won't need to help you with those. So if you need any help today, I'm here. And have a blessed day.